Hello, in this lecture we'll prove Stewart's theorem. In a nutshell, Stewart's theorem gives us a relation between the lengths of the sides of the triangle to its CVN. The CVN here is line segment AD. Okay, and according to Stewart's theorem, we know that in this triangle ABC, side AB equals to C units in its length, side AC equals to B units in its length, and side BC equals to A units in its length, and the CVN of this triangle ABC is D. The CVN is AD, line segment AD, and line segment D equals to D units in its length. And according to Stewart's theorem, the following equation is true: that B squared times M, and M is the length of side line segment BD, B squared times M plus C squared times N equals to A is the length of side BC. A, we open brackets, inside the brackets we have D squared, D is the length of side AD, that is the CVN, so it is the length of the CVN squared plus M times N. Repeat again. According to Stewart's theorem, B squared times M plus C squared times N equals to A. In the brackets we have D squared plus M times N. Okay, so we will define this angle ADB is theta. And according to the rule that the sum of the angles on one side of a triangle is equal to 180 degrees, so we know that BC is one side of triangle BC, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line BC as point D, we know that the sum of the angles on the upper side of BC at point D, the sum of the angles must be equal to 180 degrees. So which angles we have on the upper side of BC at point D? We have this angle that is theta. Therefore, this angle must be equal to 180 degrees minus theta. Repeat again, in order to complete the sum of the angles on the upper side of the straight line BC at point D to 180 degrees, this angle must be equal to 180 degrees minus theta. Why? Because 180 degrees minus theta plus theta equals to 180 degrees. That is the sum of the angles on one side of a triangle. Okay? So we will implement in this triangle ABD, the law of cosines. Okay? So I will remind you quickly what is the law of cosines. So if we have triangle ABC, that could be any triangle this is triangle ABC, that could be any triangle. And we know that side AB of triangle ABC equals to A units in its length. The length of side AC is B, it equals to B units in its length. And side BC equals to C units in its length. And we also know that the angle between side BA and side AC is theta. Then, according to the law of cosines, we get that C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Here we will add 2 times AB cosine theta to this equation. 2 times AB cosine theta. And we get that 2 times AB cosine theta plus C squared equals to A squared plus b squared. Here we will subtract c squared from this equation and we get the 2 times ab cosine theta equals to a squared plus b squared minus c squared. Here we will divide this equation by 2 times ab and we will finally get that cosine theta equals to a squared plus b squared minus c squared over 2 times ab. So in any triangle ABC could be any triangle, cosine theta equals to a squared plus b squared minus c squared over 2 times a times b. We'll implement the law of cosines in this triangle ABD. Okay. So in this triangle ABD, cosine theta equals to m squared plus d squared minus c squared over 2 times m times d. Repeat again. In triangle ABD, the green triangle ABD, this triangle ABD, according to the law of cosines, this angle is theta, so cosine theta equals to m squared plus b squared minus c squared over 2 times md. Okay. In the next step, we will implement the law of cosines in the pink triangle ADC. This pink triangle ADC. According to the law of cosines in this triangle ADC, we get that cosine 180 degrees minus theta, this is the size of angle ADC, it is 180 degrees minus theta, so cosine 180 degrees minus theta equals to d squared plus n squared minus b squared over 2 times d times n. I'll repeat again. In the pink triangle, this is the pink triangle and this is the green triangle. In the pink triangle ADC, according to the law of cosines, we get that cosine 180 degrees minus theta equals to d squared plus n squared minus b squared over 2 times d times n. Okay. According to the trigonometric identity, that cosine 180 degrees minus theta equals to minus cosine theta, we'll substitute cosine 180 degrees minus theta by minus cosine theta in equation number 2 here. Okay, and we will get that according to equation number 2, cosine 180 degrees minus theta is minus cosine theta. And it is equal to t square plus n square minus b square over 2 times d times n. Okay. In the next step, we will multiply this equation number 1 by minus 1, and we will get that according to equation number 1, cosine theta times minus 1 is minus cosine theta. And it is equal to minus, we multiplied, of course, both sides by minus 1, minus, inside the brackets we have m square plus d square minus c square over 2 times md. Okay, so this is equation number 1 after we multiply it by minus 1. Okay, in the next step, we'll create equation number 3 that states that cosine theta minus cosine theta according to equation number 1 must be equal to minus cosine theta according to equation number 2. So according to equation number 3, cosine theta minus cosine theta according to equation number 1 is equal to minus m square plus d square minus c square over 2 times md, and it must be equal to minus cosine theta according to equation number 2. And according to equation number 2, we found out that minus cosine theta equals to d square plus n square minus b square over 2 times dn. So actually, this is equation number 3. Equation number 3 states that cosine theta according to equation minus cosine theta according to equation number 1 must be equal to minus cosine theta according to equation number 2. Okay? So in the next step, we will multiply this equation number 3 by 2d, and we'll get that according to this equation number 3, so here we have in the denominator 2 times AD. If we multiply 2 times MD by 2 times D, what is left is here in the denominator is M, because 2D will get cancelled. So in the denominator we have M. In the numerator we have M square plus D square minus C square. And it is equal to, so we multiplied this side of the equation by 2d. So here 2d will get cancelled in the denominator, so in the denominator we left only with n. In the numerator we have d square plus n square minus b square. So here we'll cross multiply this equation number 3, and we'll get that according to equation number 3, n minus n times m squared plus d squared minus c squared equals to m times d squared plus n squared minus b squared. Okay, we will open the brackets on both sides of this equation number 3, and we'll get that according to equation number 3, minus n times m squared is minus n m squared minus n times d squared is minus n d squared minus n times minus c squared is n c squared. Why? Because minus times minus is plus, so it is plus n c squared, and it is equals to m times d squared is m d squared, m times n squared is m n squared, plus m times minus b squared is minus m b squared. So in conclusion, according to equation number 3, we found out that minus nm squared, minus nm squared minus nd squared plus nc squared equals to md squared plus mn squared plus mb squared. Okay, so according to equation number 3, we actually found out that md squared plus mn squared minus mb squared. Here we will add nc squared to this equation, so here it will be plus nc squared. Actually, we'll subtract nc squared from this equation, so it will be minus nc squared. In this side of the equation we have minus nc squared, in this side of the equation we have 0. And nc squared minus nc squared is 0. We will add nd squared to this equation, and it will be nd squared. Here nd squared minus nd squared is 0, plus nm squared. Plus nm squared. Here nm squared minus nm squared is 0. So in this side of the equation we have 0. Here, and there, so in this side of the equation we left with 0. Okay. In the next step, we'll take out d squared as a common factor from this expression and from this expression. So here d squared is a common factor. What is left from md squared after we took from it d squared as a common factor? What is left is actually m. What is left from nd squared after we took from it d squared as a common factor? What is left is actually n. Okay, and it is plus. Here we will take from those two expressions n m as a common factor, what is left from mn squared after we took from it mn as a common factor? What is left? First of all, we take what is left from nm squared after we took from it nm as a common factor. What is left is actually m. What is left from mn squared after we took from it mn as a common factor? What is left is actually n. And it is minus mb squared minus nc squared equals to 0. Here we will add mb squared plus nc squared to this equation, and we get that according to equation number 3, d squared m plus n plus nm m plus n equals to mb squared plus nc squared. We added mb squared plus and also nc squared to this equation. So those two expressions will get cancelled. And on the other side we have mb squared plus ac squared. Here we will take m plus n, we'll take out m plus n as a common factor from those two expressions, and we get that here m plus n is a common factor. What is left from this expression after we took from it m plus n as a common factor? What is left is actually this square. What is left from this expression after we took from it m plus n as a common factor? What is left is actually m times n. And is equal to b squared times m plus c squared times n. In the drawing we can see here in the drawing BC equals to A and BC also equals to m plus n. That is to say m plus n equals to A, and therefore we substitute m plus n by A. Okay, in the question number 3, and we get that m plus n is A times d squared plus m times n, and is equal to b squared times m plus c squared times n. Okay, and this is exactly Stewart's theorem. You can see here we have to prove that b squared m times c squared n, here b squared m plus c squared n equals to A. Inside the brackets we have d squared plus m times n. A d squared plus m times n. So we proved Stewart's theorem. In the next step I will summarize the lecture. Okay. In this lecture we proved the equation of Stewart's theorem. In a nutshell, Stewart's theorem gives us a relation between the lengths of the sides of the triangle to its Cevian. Repeat again. Stewart's theorem gives us a relation between the length of the sides of the triangle to its Cevian. The Cevian here is line segment AD. Okay? And according to Stewart's theorem, b squared times m, b squared times n, plus c squared times n equals to A. A is the length of side BC, and we open brackets. Inside the brackets we have d squared. D squared is the length of the Cevian squared, the length of the Cevian squared, plus m times n. Again, b squared times n plus c squared times n equals to A, and inside the brackets we have d squared plus m times n. Okay? In order to prove that Stewart's equation is true, we defined angle ADB as theta. We know that this BC is one side of triangle ABC, therefore it is absolutely a straight line. BC is a side of a triangle, it is absolutely a straight line. So if we focus on the upper side of the straight line BC, at this point, point D, here the sum of the angles must be equal to 180 degrees according to rule number 1 that states that the sum of the angles on one side of a triangle is equal to 180 degrees. So which angles will we have at the upper side of BC at point D? We have this angle that is theta. Theta plus the missing angle, that is angle ADB, must be equal to 180 degrees. Therefore, the missing angle must be equal to 180 degrees minus theta. In order to complete the sum of the angles on the upper side of BC at point D to 180 degrees, this angle must be equal to 180 degrees minus theta. You can see here that theta plus 100 minus 80 degrees minus theta equals to 180 degrees. Exactly according to rule number 1. Okay, so this angle must be equal to 180 degrees according to rule number 1. Okay, then we implemented the law of cosines in the green triangle, triangle ABD. So what is the law of cosines? We have here the law of cosines is true in any triangle. So this triangle, triangle ABC, could be any triangle. And according to the law of cosines, we know that the length of side AB is A units, the length of side AC is B units, and side BC equals to C units in its length. And the angle BAC equals to theta. So according to the law of cosines, we get that C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Okay, here we added 2 times AB cosine theta to this equation and found out that 2 times AB cosine theta plus C squared equals to A squared plus B squared. Here, 2 times AB cosine theta minus 2 times AB cosine theta, it is of course 0. So in this side of the equation we have only A squared plus B squared. In the next step we subtracted C squared from this equation. So here C squared will get cancelled, C squared minus C squared is 0. And here we will have A squared plus B squared minus C squared. So in conclusion, found out that 2 times AB times cosine theta equals to A squared plus B squared minus C squared. We divided this equation by 2 times AB, and finally we found out that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. Okay? In this triangle ABC, that could be any triangle. Cosine theta equals to A squared plus B squared minus C squared over 2 times AB. And then we implemented the law of cosines in 2 triangles. In the green triangle, triangle ABD, and in the pink triangle, triangle ADC. So in the green triangle, triangle ABD, according to the law of cosines, we get that cosine theta equals to d squared plus m squared minus c squared over 2 times m times d. I'll repeat again. According to the law of cosines, in the green triangle, triangle ABD, we get that cosine theta equals to m squared plus d squared minus c squared over 2 times AD. Over 2 times MD. Again, cosine theta equals to m squared plus d squared minus c squared over 2 times m times d. Okay, then we implemented the law of cosines in the pink triangle, triangle ADC. According to the law of cosines, in this triangle, pink triangle, triangle ADC, cosine 180 degrees minus theta, this angle, equals to d squared plus n squared minus b squared over 2 times d times n. I'll repeat again. In the pink triangle, triangle ADC, cosine 180 degrees minus theta equals to d squared plus d squared plus n squared minus b squared over 2 times d times n. According to the trigonometric identity that cosine 180 degrees minus theta equals to minus cosine theta, so we can substitute cosine 180 degrees minus theta by minus cosine theta. Here we did it here. We substituted cosine 180 degrees minus theta by minus cosine theta, and here it is equals to d squared plus n squared minus b squared over 2 times a dn. Then we created equation number 3 that states that cosine minus cosine theta according to equation number 1 must be equal to minus cosine theta according to equation number 2. But first of all, we multiplied this equation number 1 by minus 1. So cosine theta times minus 1 is minus cosine theta, and we also multiplied this side of the equation by minus 1. So it is minus m squared plus d squared minus c squared over 2 times md. Then, as I already said, we created equation number 3 that states that minus cosine theta according to equation number 1 must be equal to minus cosine theta according to equation number 2. Minus cosine theta according to equation number 1 is equal to m squared plus d squared minus c squared over 2 times md, or minus m squared plus d squared minus c squared over 2 times md. And it must be equal to minus cosine theta according to equation number 2. And we have already found out that minus cosine theta according to equation number 2 equals to d squared plus n squared minus b squared over 2 times dn. D squared plus n squared minus b squared over 2 times dn. Okay? So here we multiplied this equation number 3, by 2d. So here, so it is 2d. So here 2d will get cancelled in the denominator. So in the denominator we left only with m. So in this side of the equation we have minus m squared plus d squared minus c squared over m. And of course multiplied this side by 2d. So 2d over 2d is 1. And in the denominator we left only with m. So in conclusion, found out that in this side of the equation we have d squared plus n squared minus b squared over n. Okay? So we got this equation, and we of course multiplied this equation, and we found out that this, according to this equation number 3, m times d squared plus n squared minus b squared equals to n times minus n times m squared plus d squared minus c squared. Okay, of course multiplied this equation. Okay, here we open the brackets and we found out that minus n m squared minus n d squared plus n c squared, minus times minus is plus, so it is plus n c squared. Here minus nm squared minus nd squared plus nc squared equals to m, we open the brackets here, md squared, m times d squared is md squared, m times m squared is mn squared, m times minus b squared is minus mb squared. So in conclusion, found out that in this side of the equation we have md squared plus mn squared minus mb squared. Okay? So, in the next step, we took out d squared as a common factor from those two expressions. Okay? So, here we have d squared. But first of all, we actually subtracted nc squared from this equation, so it is minus nc squared, so it is md squared plus mn squared minus mb squared. We subtracted nc squared from this equation, and so we have in this side of the equation minus nc square, and we also subtracted mn square from this equation. So in this side of the equation we have here md square plus mn square minus mb square. Again, we subtracted nc square from this equation, so here we have minus nc square. We added nd square to this equation, so here it is plus nd square, and we added nm square to this equation, so it is nm square. So all equals to 0. On the other side of the equation, we left with nothing. Okay. Here we took a common factor from those two expressions. So inside the brackets we have m plus n. Here we took nm as a common factor from those two expressions, and therefore inside the brackets we left with m plus n. And we have also minus mb square minus nc square equals to 0. So here we have d square plus m d square times m plus n plus nm times m plus n, and here we added mb square plus nc square to this equation, so here we have that is equal to mb square plus nc square. Okay, then we took n plus n as a common factor. We took out m plus n as a common factor from those two expressions, so inside the brackets we left with d square plus m times n, and it is equal to b square plus c square times n. Okay, but from the domain it is very easy to see that m plus n equals to a. Here m plus n equals to a. It is the length of side BC. It is equals to a. It is also equals to m plus n. So we can substitute m plus n by a. So we substituted m plus n by a, and found out that a times d square plus mn equals to b square times m plus c square times n. And this is exactly the Stewart theorem. So we succeeded to prove Stewart's theorem. Okay, thank you very much.